So what happened, Rod?
A small hose came off on the PSRU recovery tank. Just evidently, in the process of putting everything back together, it didn't get tightened down.
Take the camera.
Yeah, but that's all I know. But you can see it.
Ezra, can you say Bowerspony Flight 13?
Dara.
Say Bowerspony Flight 13. All right, welcome to the flight video for Flight 13 of the Bowerspony. I'm in my son's bedroom right now where I've set up a makeshift office working from home during the epidemic. This is a challenging flight. So Flight 13 ended up having some interesting scenarios for us to deal with. We had a failure of a line in the engine compartment, an oil line, that led to a loss of propeller control. And then we had to shoot a relatively interesting emergency landing back into Visalia. We come away from that with several lessons learned, both on the practical side in terms of specific things that could be done differently on the airplane, and then on the more theoretical side as far as preparing for flights and dealing with these specific types of emergencies. In the meantime, this is sort of a new format, so besides having doing it from my son's bedroom, there's been a lot of feedback on the internet about more technical briefs on the videos, and as a result, this is a very technical, very long video. It's the longest flight video that we've done, and I tried to go into as much technical depth as possible. So if you notice in the description of the video below, there's some timestamps of where things are happening in the video, so you can jump around if you want to skip right to your favorite part. And if you have any feedback about this new format for our videos, if you like it, don't like it, you think it's too dry, or you want to go even deeper or whatever, let us know. The goal here is to share lessons learned with the experimental aircraft community in order to hopefully minimize the number of times these mistakes need to be made so we can all do better. So we'll get started here first with the pre-flight interview with Rod Bauer and Eric Ritter before the flight. So this is before we flew, just debriefing, them debriefing me on the maintenance that had been done during the, let's see, it was 6 months that the airplane was down between Flight 12 and Flight 13. You'll see, we'll talk about it a bunch here, but Flight 12 was a really short flight where we landed to check the belly and see if the airplane was leaking, and found a big puddle of oil under the airplane, which then led to teardown. But they'll brief that now. So it's been a couple months since we flew. You did some work. Right. So yeah, tell me about what happened.
Well, it's sort of like 2 steps forward, 1 step backwards. Issue with a leak on the pinion shaft seal going into the PSRU. And it took quite a bit of effort with regard to finding the right seal combination. So another issue is the sequencing. That was it's been the system's working well now, but it's,
the gear sequencing.
Basically learning as we go along, but basically how to do it. Because there's not exactly what you'd call an instruction booklet out on these things, So Eric's put a lot of time in this thing, and so this is a guy that's he's
one of them.
Well, he's one of them, but he's the main guy. He's the guy that's made this possible, and because of my back situation. I can't really help very much physically. I can stand around and criticize, but no, just all kidding aside.
So after Flight 12, we found a leak. Like we landed, we just did a quick hop, and we landed, and there was oil coming out. Where was the oil coming from?
PSRU input shaft. Input shaft being between the engine and the PSRU, that prop speed reduction unit.
So a lot of the time that was spent
So when we had the engine apart, we had put a new seal in. Exact same seal that was in there before. Put it back together. We tried flying it again. Come back down. We had quite noticeable oil leak. So we took it back off, put another seal in it, figured maybe we damaged a seal, that little spring that goes around the inside of the seal to keep pressure on that snout. We figured maybe something happened there, or we damaged the seal putting it in, but we couldn't find anything wrong. So I think the third seal, I hate to say the third seal, but third time putting the PSRU and propeller back on the airplane and running around, it would be fine, leak free, and all of a sudden you come out in the hangar the next morning and you got a big puddle. So at that point we realized, hey, it's not just a seal issue, it's not the wrong seal possibly. We decided to check for runout, and that's when we found big runouts. That shaft is wobbling inside that, pulling on that seal and creating a leak. So the new seal that runs...
And how much was the runout?
Over 10,000. I think it's like, what, 14,000 it was? Or how
The runout was 10,000.
10,000? Yeah,
Okay.
it was quite a lot. So the new seal we got, and I say seal, it's a lot like an axle seal on a car. So that new seal has got fingers that go all the way around, and its ability to hold in oil is a lot better, and then the seal is a lot thicker as far as the seal width goes. So we've had zero issues. We've had it in the airplane for about a month.
Yeah.
No leaks, and we've run it.
It's a real trial,
About an
a real trial and error thing as far as getting the right seal, and then we didn't realize there was a runout on that thing.
And so you say you were able to fix the runout by reclocking the pinion.
Reclocking, yeah.
Correct. So on the flywheel, a lot like a car, because this engine's in the aircraft backward, you got the flywheel, then the PSRU, and this snout comes out and drives the PSRU off the flywheel. So this flywheel is a dampener as well. So that dampener is set up with marks to indicate for balance. But you could still, when you put it all together, you could be off. And so that's wobbling around. So when Rod says we had to clock it, we had to take it loose and move it and clock it and get it right to where we're in. I think we're in 1,000ths, maybe 2,000ths at most is what we ended up
Between 1
with.
and 2,000.
So that assembly, the tolerance stack up of the assembly, you can move that around.
Correct. So when in our engine disassembly, we have three components. We have that snout or that shaft, and then you have a balancing plate, and then you have the flywheel. So those three items have to line up and be balanced, so we don't get any wobbling effect, for say. But we didn't realize that it can shift or move a little bit, and that shift or movement after the assembly causing it to wobble was not necessarily damaging the seals, but it's pulling on it, and you're getting seepage. So that was our finding on the oil leak for the PSRU.
Okay, so the gear, the hydraulic system is really complicated.
Sequences and stuff in the landing gear. So on our last flight, you noticed that the inner gear doors were staying latched, but our main gear doors or gear legs were coming open and coming down. So as I had talked about with the Thunder Mustang, forks we had used and stuff, we have these tombstones that come off the forks with a bolt, and that gets captured up in the bear claw, latches up in the wing. So we had found that after running the gear with the doors and legs and everything off, that we weren't quite getting good enough capture. It was right in between latching and on-latching. So, at speed, 200 knots, hydraulic pressure and latching it wasn't enough for the hydraulic pressure to hold it closed. And our latching capability wasn't there. So we don't know if it was stress on the aircraft as far as positive load on takeoff or what the deal was. But we have changed the diameter of that bolt that gets captured in that bear claw.
Okay.
And it has positive lock, and we're able to release all hydraulic pressure from the hydraulic system and keep capture and pull, tug, and can't get it to come down. So that was what our landing gear fix was. We ended up just changing the diameter. We put a sleeve over the bolt so it captures that bear claw, kind of like your car door. It's got a bear claw latch.
Yep.
Same type of deal, lock. It's heavier stuff than what's in your car, but anyway, we're getting much more positive engagement now. So
And then you talked about the sequencing, the hydraulic sequencing,
Yeah.
independent of the. You were talking about all the uplocks and all the different pieces and how they all play together. So is that independent of the bear claw, the latching mechanism? Or
yeah. So the uplocks are all mechanical.
Right.
There is. We went through this last time too with our landing gear stuff. That P1 actuator.
Yeah. Right.
That can help with hydraulic to release the bear claws.
Okay.
For the inner gear doors have mechanical latches.
Okay.
And so do the gears and gear legs have. So essentially
Sure.
there's probably six total, 3 per side. One holds the main gear and fork up. The other 2 hold the inner gear doors.
Okay.
So those are all mechanical.
And it all has to be rigged.
Yeah.
That all ties into this problem of the
Correct.
pins being
and then
too
when we
thin.
say,
For the...
micro switches and stuff, you have a micro switch that gives you an indicator lights for being
Sure.
extended or retracted. You have micro switches that show the sequence of the gears as far as movement. Are they stowed? Are they not
Right.
stowed?
In order for the controller to know what to do next.
And then you'll have electric motor that will open and close a gate valve for the hydraulic system to know when to. Okay, it started to retract the gear has broke away from the lock switch, and it knows to open the gear door, allow it to come up, it sees it's closed, and it closes the gear door. At that same time, hydraulic pressure is stowing the gear and the inner gear doors, and so are the mechanical latches. Literally, there's no manual for this. A lot of these parts on this aircraft are the first off parts or the benchmark parts for a lot of these other guys in their aircraft. So there's no manual on how to diagnose this thing. And when Rod talks about sequence, that's our diagnostic flow on what we go through. Okay, is it a hydraulic pressure issue? We know now how to eliminate and figure this system out, how to just, what's the word I'm looking for? We can just take one part or one section of the system and isolate that system to do testing. We learned a lot with.
Yeah, we've learned a lot.
We went from trying to figure it out to, we're able to block off and we can test each individual cylinder if we want to see if we do have leakage or, leak by. We can test the system to see if it is latching and where to look and find out if it is working.
Well, we found out that when the propeller was off the airplane and sitting in the propeller jig, that the oil would run out of the dome, the pressure dome. It would run down the back of the backing plate on the spinner. And so we put the prop back on, and all this oil slinging around. We thought, oh my, the prop seal isn't working. So we took the prop off again, and Eric says, maybe we ought to drill a hole in the bottom. And we drilled almost a quart of oil out of the back of that spinner.
Came around the backing plate in that spinner.
And the oil was coming from when the prop was sitting in the stand. It was draining down the back, out of the hub, down and collecting like in a reservoir in there. And we didn't realize that. And when we started it up, all this oil slinging around, we thought, oh, the seal's not working. So pretty frustrating, but we learned a lot, and we share that on our website. So, it's
on the Stewart Mustang.
Everybody benefits from it. It's just,
So the problem with the PSR issue is, number one, it can blind the pilot really quick. Number two, it doesn't look any different than an engine oil issue, right? An engine oil is obviously catastrophic from in the cockpit or from chase, right? It's going to look the same.
Yeah.
And the biggest thing is we're going to lose control of the propeller, which we've already played that game. So very quickly, a simple PSRU leak issue becomes a much bigger issue and snowballs, right? Obviously, if there's a rigging issue and the gear is stuck up, right? Making sure, so it'd be a good thing for us to talk about emergency extension procedures and, what do we expect there as far as any issues that might happen. I don't plan to cycle the gear beyond the one time, right? So suck the gear up for takeoff, go fly around, throw the gear out for landing. But I think we should make sure that we have plenty of gas on board so that in the event that we go to extend the gear and the gear doesn't go down, we have time to work that.
Sort it out and diagnose and try to get you down.
so we're doing a shakedown flight. Goal is to keep it less than an hour. We got plenty of gas, so the tanks are full, so let's
Just feel it all.
plenty good there. Power settings for today, I'm going to use takeoff power at 42 inches, 4,200 RPM. Climb at 30 inches, 3,500 RPM. And cruise at 25 inches, 3,000 RPM. Whatever works. So come out of the chocks here, so we'll get started. We'll do your EFIS, or we'll figure out how we're going to do that. You're going to taxi out first. CTAF today is 123.05. We use button 1, 123.45. Button 2, 127.47. Used Jumbo before.
Sounds good.
You want me in with him first or second flight?
We'll do the first flight.
First. All right, no problem. I'll grab my headset.
So you'll beat me out. We'll go 1-2. Once we're done with run-ups.
1-2.
What were they saying? 3-0.
It's called, so we go either way.
Okay.
So
Whatever
3-0.
you want to do, yeah.
We'll go 3-0. So we'll go down to 3-0. We'll do the run-ups once everything's good. We'll give you a thumbs up, then you launch. We'll do airborne pickup. So I'm waiting for your call. Brake release now.
Sounds good.
At which point we'll set takeoff power. Airborne gear up. Climb at 140 for 10,000 feet. Come back to climb power once we're out of the airport area. Once we're past the fence on the far end, or unless you're really complaining a whole lot. I'll do left turns on the way up. Try to find our way through the ceiling. Once we get 10,000 feet, I'm going to come back to cruise power, and we're going to try to get the total duration to less than an hour. So it'll be like 15 minutes or something up there in cruise. Power back for RTB, and then we'll do a overhead approach. Not quite a high key, but something like that. Real low energy approach.
Copy.
That works for you.
Sounds good.
Talked about frequencies. You'll have the camera and your. Will there be a handheld on the ground?
I don't have one. Do you?
I just got my phone. I didn't charge up the GoPro or anything. I was expecting the...
Radio though. You got a handheld radio?
Yeah, I do. Who wants the radio?
So the concern is if Eric's with us, for you guys to have SA, that you keeping Rod informed as to what's going on. That's sort of.
I have a radio in the hangar, and I got one in the truck. I'll give you. It's got a headset and everything.
You guys know how.
Yeah, it's all good.
Gotta stay legal.
Custom made.
I'll go grab that, and I'll grab my headset too
Okay.
when we're done.
Okay. That's all I have. Do you have anything else?
Sounds good.
Taxiing to Stewart's actually really nice. Nose is a little bit long, so you do have to S-turn it, but nothing too serious. It has a tail wheel unlocking mechanism, much like a T6, a G model T6 or a Mustang. So here you can see you push the stick all the way forward, bink, and then that allows the tail wheel to free caster. So here it is from the tail, you can see, bink, there it goes, it's unlocked. And then normal engine run up. So the airplane has 2 sets of ignition, just like any other aircraft engine. In this case, one's electronic and one's magneto, so let's check a nose, and then a propeller check. So just wiggling the propeller knob, making sure the propeller pitch changes as expected, oil pressure moves, etc. Then a thumbs up to Justin to let him know we're done with the run up and ready to go.
Yeah, so we launched out of 3-0. Eric and I did an airborne pickup. I was a little behind. I tried to remember how I did it last time, and it seems like I definitely did better last time. But anyway, we got a little bit of action on the climb up. As Elliot pulled left, I was able to shoot underneath, get a big picture of the belly. There was nothing coming off the back. There was no black on the belly. So it looked clean there. And then we were basically just playing catch up the whole way up to altitude. 100 knots indicated, and 1,100 foot per minute climbs. Nothing what you got. So
here goes Justin in the Tango Time Machine taking off his chase. So doing the airborne pickup, his goal right now is just to fly a big traffic pattern and set himself up to be there on my wing as I break ground. As Justin mentioned, he ended up releasing a little bit early, you can see that here in a minute. There's a little bit of an issue right about now in time. There's a jet on 10 mile final. And since the airborne pickup can kind of confuse people at a little airport, I try to be assertive, get right past that whole short line, let them know that we had the airport, at least for the time being. Right now, probably the most important thing is set the friction lock and pull the propeller governor back to 4,200 RPM. So otherwise, a prop will over-rev on takeoff. So here you go, power's coming up. Justin made his 15-second call. You can see the tail strut start to stroke as I put about 25 inches on the airplane, getting ready for that brake release call from Justin. And then we're going to jump to the chase view as Justin's coming down the chute, getting ready to call brake release now. So here he is, just offset on the right side of the runway, so that I'll be on his window. We get the brake release now. Power stood up to 42 inches. Check governor at 4,200 RPM, and pretty quickly you're coming up to flying speed. You see tails up, airborne at 70 to 80 miles an hour. There, something like that, getting airborne. And then offset to the right to effectively lengthen the runway, select gear up. Big question on this flight obviously was gear performance. Just one, that it would go up, and then two, how fast it would go up. Gear actually ended up going pretty quick, so I felt a lot better once I felt it hit the up locks. It makes a big thud in the cockpit, you can really feel it. And then I knew Justin was pretty sucked, so I'm trying to not waste any time getting back to climb power to give Justin a chance to get on board. Here's the external shot. Man, it's a pretty impressive sound. There's the offset to the right. Big left turn. So we talk about what we learned from this flight, or what were the big takeaways. A lot of it starts right here. So as you can see, there are clouds in the area. The forecast was overcast. It had turned to mostly cloudy. When I was coming up from the south, Bakersfield was clear, and we convinced ourselves that mostly cloudy was a conservative call, which is why we had pushed. Once I got to Visalia, it was definitely partly cloudy, and then but it did get heavier as the day went on. The clouds went from about 4,000 feet to about 7,000 feet, something like that, which is only an issue when you're on a high-risk flight test. So what we're doing right here is the only reason we had Chase aboard, the justification was that he was going to be looking for oil on the belly as an indication that the PSRU had started leaking again. So here he is trying to keep up. I pulled the power back now to cruise power or even lower, and I'm in this really dangerous spot where I'm held down by the clouds to 3,500 feet, something like that, and I have to go slow. And because high key in this airplane with the prop fine pitch is like 6,000 feet, you really don't want to get very far from the airport. You really want to know if the airplane's leaking oil. And so you have sort of a choice. You can pull power back, let Justin get on board and try to figure out if there's oil. You can skip that step and just keep climbing. Or you can RTB. And so what we decided to do was hold and let Justin just take a peek. And so we circled around for a while. Justin got in position, came screaming across the belly, and just looked. And I think if it had been leaking there, the glance was so quick and the oil was so new and clean, I don't know that he would have seen it. But it ended up really getting rid of a lot of the value that Justin had by being there. Once he got that snapshot, so that's this angle coming up right here. So they climbed up the rope, got set up on the inside of the turn, and then once he was a little fat on energy, jumped across the belly, took that one quick view at the belly, said, "You're clean," and I started the rest of the climb up to get above the clouds. The idea being we would meet above the clouds at 10,000 feet. He could take another look at the belly before we do that 15-minute cruise portion. So here's leveling the wings, starting the climb to get to the cloud base. The problem was that what ended up happening was, as we got to 8,000 feet and the prop failed and effectively we lost the engine, we now had to not only negotiate back through the cloud deck, but also maintain separation with each other and not lose track of where the airport is. Remember, the high key on this airplane with the fine pitch propeller is 6,500 feet. So basically the time you would have been from high key to low key is all masking the airport with clouds. And you're trying to find a hole to get back into the airport. And then, so basically you're going to show up, if you're lucky, at low key, somewhere near where you want to be in dead stick and try to make the landing. So that's what we ended up doing. So this is right before the failure. We're just coming up on 8,000 feet. Justin's about 1,500 feet below me. Getting up into the cool air, so I reached down to close the cooling exhaust door. So you'll see that door start moving there just underneath the stars and bars on the right side of the cockpit, or the right side of the frame there. just as this is happening is actually as the propeller governor is losing oil. So you can see the RPM changing there if you look at the propeller. But in the cockpit, so we'll jump to the cockpit, same moment. See that gauge in the second row all the way to the left? That's the tachometer. There's two tachometers. That's the analog gauge. There's a digital gauge on the ether. So I'm getting intermittent RPM indication on the analog gauge, and then I reach under with my left hand and I'm closing the cooling door, which is changing the sounds inside the cockpit. And all this is disguising what's actually going on, which is that we've lost, initially it was like 50 RPM and then like 100 RPM. So you can see there I'm adding power because I noticed that something changed. So I'm adding power because the manifold pressure had bled off with altitude, so I add a little bit of power. And then that's when it hits me, this isn't 50 RPM, this is 100 RPM, and it's dropping off pretty fast. So you see my left thumb slide forward as I push the propeller governor forward. And there we've now confirmed there's a propeller governor all the way forward. The RPM did not go up, so we've lost control of the propeller. So now I'm making the call back to Justin that we're RTB and that we'll be heading back to the airport. You can see we're directly over the airport, 8,000 feet. So in this moment, we have a lot of decisions we need to make pretty quick. High key, like I said before, we're 6,500, so we're only 1,500 feet above that, and we have this major problem with clouds in the way. Also, we have airborne chase available, so we want to make sure that at the very least we don't run into him, but also if he can provide some assistance, we want to give him every chance to do that as possible. So here you can see I start S-turning to get a picture of where are the holes in the clouds, which hole is going to work out the best, where is Justin, so that I can give him good heads up on where I am and where I'm going as I try to work this scenario of getting back to the airport. So here we are a couple seconds later. You can see him just above the tops, or just below the tops of the clouds now. We found a hole that we like that's pretty much over a left-hand SFO pattern for the runway 30 at Visalia. And now the biggest problem we're having is I can't put enough drag on the airplane to get down through any of these holes. So we had set up all of our emergency patterns with the prop in fine pitch, so 4,200 RPM. The prop is currently at 1,500 RPM and I can't control it. So therefore the airplane's a lot lower drag than I've ever had to shoot an emergency approach with. So trying to find out the best place to be as we transition from above the clouds to below the clouds, and from sort of what would be a hybrid high key approach to a hybrid low key approach to finally final is very critical. And then using Justin as a second set of eyes to visualize that. So it turned out there was a big cloud directly over right where high key would want to be. So what I ended up doing was going to low key geographically and then circling down to low key from just above a high key altitude. So here I am at low key, looking over at the airport, judging my energy state before I make the decision to go ahead and extend the gear. So there goes the gear. Again, dropping the gear in a high drag configuration is a really dangerous decision. In this situation where we're in a low drag configuration, I probably could have dropped it earlier, especially when you see the S-turns I had to make this approach work. So just coming off a low key, you can see the gears down, flaps are up. We are just very much at gear speed, trying to put just as much drag on the airplane as possible. And here we are on final. And you can see I'm off runway heading. So here you can see the deep S-turns I had to make in order to make this approach work. So once again, if this had been the high drag configuration with the prop in fine pitch, I would already be way too low to make the airport. In this configuration with the prop course, I end up being pretty heavy on energy, and so that's where you can see these deep S-turns to try to make this work. Justin is about a half mile behind me, on runway heading, providing SA as to any traffic that might be in the area. So now that I was confident I had the airport made, flaps go down, and take runway heading for the touchdown. It's one of the faster landings I've ever done in the airplane. But got it down without any major incident. Right now, Justin called on the radio, asked if I thought I had enough power to taxi. it turned out that even at course pitch, the engine had enough power to taxi. So I was able to taxi back to the hangar without having to be towed back. So backing up just a little bit, here's the approach from the helmet cam. There had been a big bunch of discussion before the flight about whether or not oil would blind the pilot. So from this angle, you can see there was oil going up and on the windscreen. It was not an issue on the approach, but interesting that it was something we talked about before the flight, and it ended up happening. Luckily, as you can see from the external shots, most of the oil ended up coming out actually after we came to a stop. So other than this shot where you can see oil on the canopy and on the windscreen, there really is no other views where you can see oil coming out of the engine. We kind of hoped we'd be able to see that moment where the line came off and oil sprays everywhere or whatever, and that's not the case. So here as we're taxiing back, you can see the prop is at course pitch, and if you listen, the engine sounds much different. I'll turn the volume up here. Very quickly, I'm outrunning him, right? I can climb way better than he can. So the question was, do I stay in the big power setting? We had set 35 inches. All the way up above the clouds, and then have him check, or have him check below the clouds. So we tried to do a check below the clouds. So what I did was I turned really hard so the geometry really works for him, and he comes up the rope and then ducks underneath and takes a shot. Just looks, tries to see, right? Because we were making the assumption the oil would be pretty obvious. Once that had happened and we didn't see any oil there, then I went back to climb power and got back above the clouds, and then we were just chasing each other up to 10, where we would check again. So from the clouds were what, at 4,000, something like that?
Yeah, it was like 4 to 6.
So from 4 to 8, there was no one looking at the belly. Because it was either run really low power so he can hang out, or run the power that we described and be a blind. So that's what we decided to do, was go. And then at 8,000 is when the prop ran away, or we lost control of the belly.
That's a loss.
So then the assumption is that the PSRU would have dumped all the oil overboard, at which point we would have lost control of the prop governor. So at that point I was at climb power 3,000 RPM. So as it's out of oil, then there's nothing to hold the prop in fine pitch, so it starts bleeding off to coarse pitch. At which point the RPM starts to drop off. Saw the RPM drop off, pulled the power back, and RTB'd. Then we're shooting the approach. All the practice approaches that we've done for this thing are in the worst case scenario high drag. So the prop at 4,200 RPM, which is a lot of drag. In this case, we're at 1,400 RPM, way less drag, so the whole approach had to be completely different. So between that and the clouds, we were very busy on the approach. So I enjoyed having you there, Justin.
It was fun working the geometry.
So what happened, Rod?
A small hose came off on the PSRU recovery tank. Just evidently, in the process of putting everything back together, it didn't get tightened down.
Take the camera.
Yeah, but that's all I know. But you can see it.
It's like she's up there.
Come here, Elliot. Here's our culprit. So this is your
Hang on, sorry. Okay.
came off, and it goes right back into the PSRU. So it should go right under here and just
Got it.
tighten up. I gotta look at the fitting, make sure it didn't crack or something like that. Why it came undone.
One of the issues, and I think most home builders will find out, is that an awful lot of people are looking for time to waste. So they come to the airport and they interrupt you when you're working on something, and so consequently, every time you stop what you're doing and start again, sometimes just that interruption will cause something like that.
Distraction at least.
That you just can't control it, and other than being just impolite to people.
So with this flight behind us, we'll work towards flight 14, having looked over all the other connections on the airplane and confirming that everything's tight and we're ready to go. But obviously the goal is to not have to learn these expensive lessons more than once. So as we summarize the lessons learned from this flight, I would start with first, not to beat a dead horse, but the distraction during maintenance lesson learned is something I think we've all experienced before, and this is a good reminder, something to take forward, and Rod did a good job of explaining that. Number two is rustiness, or we're in the middle of the corona epidemic, so flying rates are down. Justin and I haven't flown together much recently. I haven't done a test flight of this kind in a while, and that rustiness is visible. They always say you can tell in the briefing how the flight's going to go, and if you watch that briefing, a lot of the high points were there, but there was a lot of details that were missing that I think well, they took away from the flight, and they let Justin and I not be as available to fly the fight as we would have otherwise been. And specifically on that topic is the topic of clouds, which is particularly interesting since we're getting ready to deploy for both the Aurora program in Wisconsin and the Raptor program in Georgia, both of which are climates where clouds are much more likely than we experience here on the West Coast. So coming up with a way to deal with clouds or rules for dealing with clouds is all the more valuable. So I think we could have determined before we took off whether we were going to stop below or above the clouds or wait till we were at 10,000 feet to do that belly check that ended up being such an issue. You can call AWAS, you can find out how high the clouds are, you can figure out if you need to where the tops are, and then you can stage out that flight and say, okay, I'm going to climb to base of the clouds, 3,500 feet, I'm going to come back to cruise power, you'll come aboard, you'll check the belly, then okay, they'll stand back up to climb power and go. Or I'm going to go direct to 10,000 feet, which is what we briefed, but not what we ended up doing, and then do the belly check then, and have that that discussion about what is the value of chase, how soon is it most valuable for chase to take a look, et cetera, on the ground at 0 feet and 0 miles per hour. Another point is a maximum cloud coverage metric for this type of high-risk flight. So you can call the weather station, you can get a height of the clouds, but it's hard to get like a real quantifiable how many clouds are over the airport, right? And especially when there's a lot of pressure to get a flight off, the more you can quantify a variable, the better. I think the number is what a ceiling is at the switch over from partly cloudy to mostly cloudy, and I think based on what we learned on this flight, I think even at partly cloudy, we need to be questioning it. So the number that Justin and I are going to use, at least initially, for both the Aurora program and the Raptor program, is 20% cloud coverage. At least here initially, we'll see if that works for us. So those are the major lessons learned from this flight. We'll run through them one more time. Number one, distractions during maintenance. Number two, recognizing that the team hasn't worked together in a while. There's some rustiness, and therefore we need to make sure we go extra slow in those initial steps to get ready. And then dealing with clouds in a high-risk flight, specifically planning out if you have chase, where are you going to stop to do that belly look if that's the value chase is providing that day. And then lastly, how much clouds are too many clouds as you deal with it.